Yesterday, we started talking about the difference between integral graphs and regular graphs. We're going to continue that today. Again, very important when we get to AP exam questions. Example 10 here says the graph of y, okay, this is a graph of f of x, is shown, and capital A of x is equal to the integral of f of t dt. So label that graph real quick. Notice that every question is about A. And so this graph of f, we want to label it with A in mind. How could we label this graph? We're going to call it A what? It is A prime. Because if f, when you take the antiderivative, if you took the integral, it gave you A. If you took the derivative of it, it gives you f. So A prime is the same thing as f. If this were a free response question on the AP exam, I would need to establish the fact that A prime is the same thing as f. Now that we've done that, question A says, does A of x have a local maximum at P? Discuss with those around and make a decision. Does A of x have a local max at P? Thumbs up if A has a max at P. Thumbs down if it doesn't. Thumbs up if it does. Thumbs down if it doesn't. I'm seeing a whole lot of thumbs down, so the answer seems to be nah. No, it's not. Anybody, what would it have looked like if it was a local maximum? Somebody want to let me know that? Sam, what would it have been? Yeah, if f had a maximum, or in this case, if A had a maximum, it's going to cross the x-axis, technically from positive to negative. A prime would need to change from positive to negative. That's where maximums happen. Now that we understand area a little bit, I like really talking about this with area. So A is the antiderivative of this graph. So if I want to talk about A, I want to talk about area under the curve. What is true about the area under the curve so far? It's negative, and in fact, it's becoming more and more negative because I have more and more area under the curve all the way up till P. Then what's going to happen to the area under the curve after P? It's still more negative. It just keeps being more negative and more negative and more negative and more negative and more negative all the way to there, all the way to R. What starts happening at R? It starts to become positive. And so what happens there? What is R if you go negative, down, 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 and then you start going up? R is a minimum. Where does A have a local minimum? At R. Why? Because A prime changes from positive to negative. Or from negative to positive, sorry. A prime changes from negative to positive. That is why it's a minimum. We had an x-intercept. Visually, when you think of the area, it makes sense to you. You have a lot of negative area, then all of a sudden you got a little positive area. And so you're going from down to up again. Show me with your fingers, when does A have a local maximum? You're showing me some cool S's here, yeah? And S is a local maximum. Why is S a maximum? Well, I'm going to have negative area, I'm going to have positive area, and then all of a sudden, I'm going to have negative area again. So then it's going to go down. So if you go up and then go down, that's a maximum. You could also state that A prime changes from positive to negative. It changes from being above the x-axis to below. That's what makes something a maximum. We did that all first semester. We're really good at it. Don't lose that now. Question D is the tough one of this problem. True or false? A of x is less than 0 for all of x in the interval shown. Now, you do need a little bit of knowledge that the initial graph, that A started at 0. A of 0 is equal to 0. With that knowledge, true or false, is A of x less than 0 for all intervals shown? Talk with your neighbor, make a decision. Thumbs up if you think it's a true statement. Thumbs down if you think it's a false statement. True or false? The answer is true. Any group had a good answer as to why you believe it's true? You guys were talking about this. Kenzie, what do you guys say?
The area under the curve is negative more than it is positive.
Yeah, that's the best answer. It's negative, it's positive. We go negative forever, negative, 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 and then we go positive a little bit, and then we go negative again. If you had to estimate what this area is starting at 0 and going to R, what would you give that number? Negative what? Negative 17. Wonderful choice. Negative 17. If that's negative 17, what is that little green area from R to S going to be? Positive less than 17. We'll call it positive 1. Negative 17 plus 1, guess what? That's still negative. And so this function is negative all the time. Even though we went a little bit of positive, the numbers don't balance. All right, this is something they will do a lot. Normally it's pretty obvious that you can see, oh yeah, there's definitely more down below than above. Just use your brain, use some common sense. Flip it over. On the next page, you've got a whole question here. I want you to work with your neighbor. There's a couple things I'm going to change on it just to make the process go a little bit quicker. So we are going to look at this graph on the interval from 0 to 12. That way we don't have to worry about infinity and positive infinity and negative infinity. So we're going from 0 to 12. On this first question, just tell me where a of x is increasing. And on this question, just tell me when it's concave down. Answer those questions with your neighbor. Talk through them. Give some good justifications. I didn't ask you to justify. Justify them anyways. All of those questions are in terms of A, so you better tell me what that graph is in terms of A. Go through those now with your neighbor. Here we go. Determine the graph of A of x is increasing. Again, they told me f of x. I wish I would have gotten a little less in the same rut of calling every one of them A. We did. If this is A and this is f, if A is the integral of f, what else could we call this graph right here? A prime. Label it. This is equal to A prime of x. If I want to give justifications, I want to be able to label those. Yes, sir?
Is it sufficient to say that y equals A prime of x? Or do you have to just
I would say f equals A prime of x. Technically, yes, since they said y equals, we're good there. So my justification, when is A increasing? What is happening with A prime? Show me with your fingers. What is happening with A prime if A is increasing? Some short of what saying positive. A prime is positive. When is A prime positive? Oh, this is a graph of A prime from 0 to 4. Remember when we talk about increasing, decreasing, it's brackets. And from 8 to 12. A prime is positive. So obviously, when is A decreasing? When it was negative, that would be from 4 to 8. Determine the values for which A of x has a local maximum or minimum. So we're talking max and min. Let's put a justification for maximum. And so since that is a graph of A prime, we're going to write our justification in terms of A prime. So A prime does what when A has a local maximum? Abby, what's happening with A prime if A has a local maximum? Yes, but more specifically, A prime changes from positive to negative. That is my justification. So if I look, when does A prime change from positive to negative? At 4. Any other place? 12, kind of. And so 12 is not going to be a local max because we were on this closed interval from 0 to 12. It's not a local max. It is a maximum. In fact, it could definitely be an absolute maximum. And we're going to get to absolute maximums here in a few days. That is a place that matters. 12 is a place that matters. It's a maximum, but not necessarily a local maximum because it's not changing like that. Remember, maximums can happen where derivative changes signs and when it's equal to or at an endpoint. And so that's when that's happening there. So x equals 4 and a minimum at x equals 8. What about this other endpoint at 0? What would that endpoint right there at 0 be? Would that be a maximum or a minimum? That's a minimum because we are starting at some spot, whatever that spot is, and then our area is positive because that graph goes above the x-axis. And so that is a minimum because you start at 0 and then increase from there. Points of inflection. If I want to know when points of inflection happen, A prime is going to do what at a point of inflection? The slope changes signs, or in other words, A prime has maximums and minimums. Show me with your fingers. How many answers did you have on this one? How many answers? Should have 3. When does slope change signs? Right there at 2. right there at 6, right there at 10. 2, 6, 10. Determine the interval where a of x. Determine the interval when a of x is concave down. If a of x needs to be concave down, that means a prime, show me with your fingers what needs to be happening with a prime. Decreasing. A prime is decreasing. When is a prime decreasing? From 2 to 6. Remember when we talk about concavity, we use parentheses, 2 to 6, and 10 to 12. Questions with anything with reading graphs? That is not the last time we do this. We will do this every day probably for the next month, but we want to make sure we're good with those concepts. We'll continue to hit them again and again. One more question here today, a different question. It's not going on the same lines as the other ones, but it's a good question nonetheless. On these questions, we are finding the total area of the region between the curve and the x-axis. What is being asked is not this. It is not this question, 0 to 3 pi over 2 of sine of x dx. Why is what I just wrote down not the same as finding the total area of the region between the curve and the x-axis? Stuart, what do you think? Yeah, so good. If we want to do total area, okay, this is some area, and this is some area. What would we do mathematically to find this, to go from 0 to 3 pi over 2? You'd subtract it. You'd have this one, and then you'd subtract that one, and would get you your answer. That is not what I'm asking with total area. And so we just discussed finding the absolute value and understanding that break. When on this graph do I care about? Looking at a graph, it's easy. Without a graph, we might have to do a little bit more work. When do I care about the split here? When's the split going to happen? At pi. And so here's what we're going to do. We're going to split this guy into 2 separate integrals. One of these integrals is pretty straightforward. We're going to start at 0, and we're going to go to pi of sine of x dx. Okay, I'm glad that's on this YouTube video. And then my next one is going to start at pi and go to 3 pi over 2. If I just found this answer, that would not be right. What else do I need to do here? Absolute value of the second one, because I know the second one's getting you negative area, because we got it right there. We know it's negative. So what we need to do right now is find this. Do that with your neighbor. Evaluate what this guy is. Evaluate from 0 to pi of sine of x dx. Get a numerical answer. Try that now, please. We're doing the antiderivative was negative cosine x. And so I'm going to plug in my upper bound of pi minus my lower bound of 0. And so when I plug in negative, pi is over here on the right side of the graph, so that would be negative 1. So it's minus a negative 1 minus a negative, so it's really plus. Cosine of 0, that's over here. Cosine of 0 is 1. So minus negative 1 plus 1 is going to get me 2. Then we would find the same thing on the second one. Negative cosine of 3 pi over 2 minus cosine of pi. Actually, it's minus a negative cosine of pi, so again, I'm adding. This guy is 0. This guy is negative 1. And so I get negative 1 there. Show me with your fingers what is the answer in the end of this problem. Your final answer should get you 3, because what do you got to do with that negative 1? Absolute value. We knew it was going to be negative. We looked at the picture. We knew it was going to give you a negative area. This guy was 2. This guy was negative 1. But because I was finding total distance, I was doing the absolute value. My answer is 3. Make sense on that one? I'm going to go fast forward through the second one. I'm not going to make us do the whole thing. We're going to go quick here. Looking at that picture, it's obvious to see when we change, right? When we can see the positive and negative slope, or in positive and negative area. We're going from negative 2 to 3. And so I'm finding that area. Obviously, there's a portion of positive area and negative area. Let's say we weren't lucky enough to have a graph. We could find this spot right here very easily. All we are trying to do is figure out when this graph is equal to 0. Because if we know when that graph is equal to 0, we are going to know when it changes from being above the x-axis and below. And so we could solve that thing. We could add 1. We could cube root it. X is going to be equal to 1. We could make a cool little number line here. This is a y graph because I'm graphing y. I've got 1 here in the middle. I'm going from my lower bound of -2 to my upper bound of 3. You could plug in some numbers like, what if I plugged in a number like 0? What would I get? If I plugged in 0, it'd be negative. If I plugged in a number between 1 and 3 like 2, it would be positive. So it just told me what that picture already told me. Yeah, at 1, there's a change in our signs. When I go to the left of 1, it's a negative area. When I go to the right of 1, it's going to be a positive area. That's all that's telling me, but we got a picture. Write the integrals that will get you the total distance based on that picture. Let's look at this thing. Michael, what'd you write your first integral from? -2 to 1 of that function of x cubed minus 1 dx. What else do you got to do with that first integral? Absolute value. Good, because we knew that the answer was going to be negative, and we want positive. So he's taking the absolute value of that first thing plus my second integral. Jack, what's my second integral going to go from?
1 to 3.
Yep, 1 to 3 of that x cubed minus 1 dx. If I were to find both of those, and we could, I don't doubt your skills on that, you add them together. That'll find your total area. Questions on something we did today?